welcome back to Omniverse Ashay, and in today's video we will be solving a GATE CSE problem which was asked in 2017 and it is related to C programming. Okay, so let's analyze the code given and then we will try to solve the problem and we will then finally come back to the solution. Okay, so yeah, this is the code snippet given and now let's start from the main function. Okay, so the first statement it is declared the memory using malloc. Okay, and since we know that malloc allocates the memory and returns the void pointer. Okay, so it returns the void pointer, but here we have not typecast it. Okay, it is not typecast. It is not typecast. So one thing which I want to tell you here is that in C programming, if we don't explicitly typecast, then also it will compile successfully. Okay, it will run successfully. But in C++, if you will execute this statement, then it will give error. Okay, if you will execute only this statement, then it will give error. So in C++, it is very strictly to give the typecasting for malloc. Okay, but in case of C programming, because since it is the code given in C only, C language, therefore we will continue. Okay, here there will be no error. Okay, so the control will come to this part. So let's go step by step and let's now first initialize the variable, means allocate the memory. So here let's say we got allocated the memory. Okay, let's say here the address of this memory is 1000 allocated in the heap memory. Okay, because it is allocated using malloc. Okay, then let's say if we got some memory, so this statement will not be executed and the control will go to the next statement. Okay, so here actually what we are doing here is we are calling the function. This is a assign value function. We are calling this function. Okay, so the control will come back to this position here. Okay, so we have called a function assign value and we are passing the address of a and also the value 0 to this function. Okay, this function we are passing address of a and the value 0. Okay, so and then we are assigning the value. Okay, assigning the value val to the pointer variable. Okay, so here what will happen is here heap will allocated value 0. Okay, there is a variable x. Let's say let's just say here x is there. Okay, x is there and it is holding 1000. Okay, it is a pointer, so it is pointing to this variable, this memory, and it is assigned to x. Okay, 0, then return x, then here we are returning x. Okay, again we are returning the address, right? So x will get back the address, so x will be having 100 only, 1000 only. Okay, why? Because the address is not changed. Okay, so address is remaining the same way as it is. Okay, then we will move into the next, then we will be moving to the next statement, if condition. Okay, so if x, this means that if x is not equal to 0. Okay, so since x is having the address, so it is not equal to 0. Okay, so we will go into the loop inside the if statement. Okay, so again we are assigning another memory. Okay, using malloc. Okay, so another memory will be allocated. So let's say here another memory is allocated and let's just say the address is 2000. Okay, and so the memory is allocated. Now again it will check the next statement, if x is equal to null. So let's say we have got successfully assigned the memory, so it will not execute and we will go to the next statement. So again now we are calling function again. Okay, so assign value is called again here. Okay, by passing the address x, address x and the value is 10. Okay, so let's jump to this function again. Okay, so yeah, x is having, now carefully notice that here address is 2000 because the new value of x was passed. Okay, so x 2000 address and 10 is the value passed. Okay, so it will be assigned using that function, right? So here we will get value as 10. Okay, so okay, we have to change this also, right? This x is actually, it is now pointing to here 2000. Okay, so x is pointing to 2000. Yeah, so we should have changed it earlier only, right? So after doing this, we will print the value of x and we will free x. Okay, these two statements. Okay, so in the next statement it will simply print the value of x. So x is containing 10, right? And after that we will free x. So this memory will get freed. Okay, but what about this memory which was allocated earlier? This is not got freed, right? So here in this case we will say we got a memory leak. Okay, memory leak. In this case we got a memory leak, so this is the memory leak. Okay, so yeah, this was the whole code, and let's try to figure out the options. Okay, so the first option, compiler error as the return of malloc is not typecast appropriately. So as we already discussed that in C it is not strictly required, but in C++ it is strictly required. Okay, so it is not our answer. Then compiler error because the comparison should be as x is equal to null and not as shown. Let's just see where it is. Okay, this statement they are talking and this statement, but there is no difference if we put either of the way. This is also fine and this is also fine. Okay, so no, this is also not correct. Okay, then compiles successfully but execution may result in dangling pointer. Okay, so there is no dangling pointer actually. What is dangling pointer? First of all, let me explain here. For example, you have a pointer variable, okay, ptr, and ptr is pointing, earlier it was pointing to a valid memory. This is a memory, okay, memory location, for example, let's say 5000. So earlier it was pointing to memory location, valid memory location, but somehow later this memory got freed up. Okay, this memory got freed up. This was not allocated now. Okay, now this was got freed up by you somehow. Okay, so then this pointer which is still pointing to that freed memory or unallocated memory, then at this point we will call it as a dangling pointer. So in our case we didn't find any dangling pointer. Okay, we are always pointing to a valid memory location here and here also, so no dangling pointer. Okay, so this is also not our answer. Then D option, compiles successfully but execution may result in memory leak. So yeah, we actually found that 2 times malloc was initiated and the first malloc was not freed up. However, the second got freed, but the first was not freed up. Okay, freed. So that's why we got a memory leak, and hence this will be our correct answer, right? This will be our correct answer. So okay, so let me try to explain you with the by running the code also. So here is the online GDB, and here I am trying to run the C program. Okay, and I have not the using malloc, I have not typecasted it. Okay, so I am simply running it. So if you see, by running it there is no error. It is simply a warning. Okay, there is no error. But if I try to run it using C++, then it will give error. Okay, so iostream, and let me select C++. So definitely it will give error. So yeah, see, it is saying invalid conversion, right? So if I if I typecast it, then it will not give error. So int star. So let me try to run it again. So now it will not give any error. Okay, so yeah, so video, I hope you got something out of this video, and if you do, then please do like the video, and also don't forget to comment your views in the video. Okay, so thank you guys, and see you guys in the next video. Thank you.